Good afternoon, ladies and gentlemen, and welcome to our final presentation of the day. We have a very special speaker today for you, Paul Meehan with Amazon Web Services. Please give him a warm welcome.
So my name is Paul Meehan. I'm on the S3 team. We have a few new features that are out here at the show, and I'm going to take you through them. So I'm going to go through access points, which we announced in the keynote yesterday. It's brand new. It's been out for 2 days now. I'm going to talk about the replication stuff that we've done. It's called replication time control. Show you some of the cool new metrics and replication features that we have. And I'm going to go back to the spring where we launched a feature called batch operations. I'm going to show you how batch operations works. So I got 20 minutes. I'm going to do 3 new features, no slides, just the S3 management console so that you can kind of see how it works. And I'll try and keep it lively since it is Thursday evening at reInvent, and we all need a little pep. All right, so I'm going to start with access points. It's the newest. There's a lot of buzz about it here at the show. We're super excited. We think it's going to have actually implications for the way that customers architect cloud storage for years to come. Okay, so I've got some access points that are sitting over here on my bucket that is called pmegan1. This is just one of the buckets that I play around with. You can see up here on the bucket page, there's a new access points tab. It's brand new, just appeared in console the other day. If I drill down into there, I can see that I don't have any access points on this bucket because I messed up my demo already. But I can go over to pmegan2 to the place where I did put an access point on and show you there because that's really where they are. Now you can see I have 4 access points that are on my bucket, right? They're called JSON docs, list objects, my kids, and test objects, okay? And the idea with an access point is that I can create basically new endpoints, new pathways into my bucket, and then vend each one of those access points out to stakeholders within my enterprise. And the benefit of doing that is several. First, I can apply an access policy to each one of those points, which means I can tailor an access policy to each one of the stakeholders to which I've vended an access point, right? That reduces the blast radius if you mess up a bucket policy, for example, and just allows you to have much more control and sort of organized, deliberate, planning for managing access into your buckets, okay? So what I've done here is I set up this access point called My Kids. Let's imagine a case. I like to keep lots of pictures of my children in my bucket. I mix it in with all my work stuff because, I don't know, I'm a product manager and I do weird stuff in order to do demos like this, right? So let's pretend I set up an access point, and the purpose of this access point is that so I could provide access to my bucket so that you folks could see all of my JSON docs, but you can't get pictures of my kids out, right? So that's the use case that I'm going to show you here. It's a dumb use case, but it's real easy to show. So I'm drilling into my access point now. You can see that I've got some specific options that I have. I can set specific block public access settings for any traffic coming in through this access point. And if I scroll down, you can see that I have the ability to set a specific access policy on my access point as well. So I've written this really simple bucket policy here that basically says, principal star, so everybody in the world, deny puts and gets in cases where the resource matches the prefix in my bucket called kids. Everyone got that? It's a super simple bucket policy. You could imagine that this is simple, but if you had 100 different variations of this and you didn't have access points and you're trying to cram them all into a bucket policy, that's where it gets super complex, right? So breaking it out in this way means that I can give the people who I don't want to have access to my pictures of my kids, they won't have access, right? So if I drop back to my bucket in general, just to the normal view of my bucket, I can drop down into that kids directory, and you can see here I could come and grab one of those pictures and open it, right? It lets me go all the way through, and I won't show you here, but you can see I'm going to go all the way through here and get a picture of that's sitting in that kids prefix right through the S3 management console. One cool thing that I can do with access points is if I drop back into the access points UI, I can go to the access point configuration and say, hey, use this access point. Now console is pointed at that access point. So when I drop back down to the bucket itself, you can see along the top nav here, I have no options, basically. I can just do gets and puts, because that's all you can do through these vended access points. So I'm effectively seeing what your clients would see being subjected to that bucket policy that I showed you that said don't allow these clients to look at the kids prefix. So then if I go into the kids prefix, remember I just banned gets and puts. So here's the moment of truth of my demo, right? If I go try and open this up and go try and open this up, it worked. I got an access denied because through this particular access point, that policy that I wrote kicked in and it gave me a 403 because I said principal star not allowed to do gets and puts, okay? So this is just a simple example where I vended out an access point, I applied a policy to it that say, hey, any client coming through this access point does not have access to a given prefix, and now any set of clients that are hitting that access point, which is effectively a bucket name or a bucket alias, they're subjected to that special set of policies. Does that all make sense? So there's like a cool way to kind of manage and scale out your stuff. You can do additional features like lock to VPCs. You could set similar policies based on object tags. Anything that you can do with a bucket policy, you can now break all that logic up and stick it onto access points instead, just giving you much smaller blast radius for changes, and again, just making it easier to manage access into your bucket, okay? So super cool new feature, and again, sort of extracting out or abstracting out the access controls from the bucket itself, from the storage, out into a separate, almost virtualized layer on top. We think is going to have cool architectural implications going forward, okay? All right, so that's access points. I have 13 minutes left. I'm going to go now, I'm going to exit my access point here. Well, why don't I just... All right. So now what I'm going to do is I'm going to drop down into a different bucket, the bucket that I showed you the first time, and I'm going to show you some replication stuff. So replication all lives under the management tag. I'm going to go into the replication configuration section. You can see here that I have a feature called replication time control on here in my replication configuration. Now, replication time control is super, super complicated to set up. Let me show you how it works. You go through your replication configuration and you check that box, and that's really all you need to do. From then on, you can just click through as you would anything, any other, just a normal replication setup, and you're good, right? So it's actually just super easy to set up. It's just that one checkbox to set up replication time control. What replication time control gets you, it gets you a 15-minute SLA on your replication performance. That means 99.9% of your objects will be replicated from source to target within 15 minutes, bound by an AWS SLA. So for customers who have compliance regulations that say you have to keep a replica that is current in N number of minutes, replication time control is a feature that allows you to do that. So, but not only do you have an AWS SLA to show for that guarantee that AWS is making for you, you also have metrics. So I can pop over to, if we pop over to CloudWatch, I'll show you some of the new metrics that we have that should be being cranked out right now on my CloudWatch dashboard. You can see I just have my handy dandy workspace. It's just a little Linux box. I'm a product manager, so I'm not a coder, but I have primitive enough coding skills to write a dumb shell script that just writes puts on a loop, right? And so this thing is just driving just 6 puts parallel puts in a loop, just driving kind of demo traffic into my primary side bucket, right? So I'm just putting big files into my primary side bucket, and when that happens, that stuff is getting replicated from Oregon, or it's either from Ohio to Oregon or Oregon to Ohio. I don't remember. But what I'm doing is I'm catching that information now in CloudWatch, and I got these 3 new metrics that you can take advantage of that are on your that are now just available for you when you turn on replication time control. The first one is bytes pending. Bytes pending is how much actual data you have that's unreplicated. So you can see here, I'm putting like multi-gig objects, just 6 threads of multi-gig objects on a loop. I'm sitting here with, at peak, about 10 gig unreplicated, and you can kind of track that replication queue depth over time. I also have operations pending, which is the number of objects that are pending at any given time. These two charts look pretty similar right now, but if you imagine a world where you put in a ton of small objects, they can diverge quite a bit. So being able to see how many objects and how many bytes are outstanding is a super useful metric. The last one here is, and we'll zoom into 1 hour. The last one here is the replication latency. Now, this one you can see I've dropped basically down to 0 at this point, just because of where I am on my puts, but I peaked out at about 30 seconds. This is an actual measurement of how far back my replication is. So for any data protection nerds out there, this would be very equivalent to your recovery point objective. So you can actually measure your recovery point objective through time. You can report on it back to the business. So if the business tells you you must achieve a recovery point objective of 15 minutes or less, you can say, hey, I got a piece of paper from AWS that says we're going to do that, and I also have this chart, this monitoring that proves that we did it over the course of the last quarter or month or whatever, right? So that's a super cool feature added to the replication process, okay? Not only do you have this report, but I'm not going to show this to you because it's hard to fake, but if we were to breach, if we were to get above 15 minutes, we'd start throwing events for every single object that breached, right? So we hope we never have to throw those events, but that's just one more layer that you can use to prove back to the business that your replication is in check and meeting the objectives that the business has set out for you. Okay, so that's RTC and replication metrics. This is also hot off the presses. This came out on November 20th. So as a part of pre-invent, the replication time control feature came out, and that's now available for you as well. Okay, so that's RTC. All right, I have 8 minutes left. I'm going to show you batch operations now. A third new feature in the product. This one came into S3 in the spring. So it's been around for a little while, but still counts as sort of a what's new. Lots of customers are still learning about it. And it's sort of a new and different feature, so I wanted to just take a moment to show you this too. It also fits in that sort of managing data at scale, which is the topic of the presentation today. So the batch operations UI sits on the left-hand nav here. You'll notice that we've been adding more and more down the left-hand nav, sort of account-wide functionality that exists within S3. Access Analyzer is another one that came in at reInvent. Block public access sits at the account level, so we're going to continue to populate down that left-hand side as customers tell us more and more stuff that they want to do with across their account to all of their buckets. And batch operations is one of those features that operates above at that account level. So the reason we built batch operations was because customers told us that, hey, I have 1 million objects in my bucket. I want to change the encryption status on all of them, or do whatever. I want to copy all of them, or add tags to all of them. If I have to do one thing 1 million times, I have to write code to do that, right? And that is not differentiated work for developers, at our the developers of our customers, right? So this is undifferentiated heavy lifting we wanted to take away from you guys, okay? So it is a fully fledged batch processing system, which I think is one of my favorite features in S3 because it's one of those examples of where cloud storage kind of really shines, right? Like you would never put a big, heavy batch processing system on an on-prem array, right? Just wouldn't make sense. But we can do it in the cloud, and so we did because customers were asking us about that sort of, repetitive, batch processing at scale, okay? So this is what we have today with batch ops. If you've ever used a batch processing product, it's kind of that, right? It gives you a job ID, it gives you a description of the jobs that you ran, the operation that you did. So you can see here I have a bunch of jobs that were doing put copies, so creating copies to another bucket. I have a bunch of jobs that were replacing tags on objects. Shows you the date, of course, the status of the job. So if it is complete, all of mine right now are complete, but if any of them were failed, like down here, or running, you would see that here. And then one of the coolest parts of batch operations is that it also shows you the total failed operations in the job, right? So here, I had 3 failures. I did a bunch of copies. I had 3 failures, which is less than 1% of all the copies that I did as a part of this job. But as any of you who have done batch processing know, like it's that last 3 that are the tough ones, right? That's where where most of your code would have to be if you were gonna roll this yourself, like truing up the exceptions, figuring out how to get into that understandable, consistent state at the end, right? And so batch ops not only tells you kind of how many failed, but it also gives you a completion report as well, so that you can go drill down and see which specific objects failed and what error codes we got on the failure. So in order to make it an easy demo and to maximize my chances of success, I'm going to show you how to clone a job in batch operations. And what that does is it takes a previous job and basically reruns it. So it's going to pre-populate the whole configuration for the job so that, my terrible typing is not going to mean that there's a picture of me blowing a demo on the internet, right? So, I specify the region that I want to run the job in. I specify that I'm going to do it out of a CSV. I could also do it out of an S3 inventory report. So you could, be generating inventory reports every night and then just running batch operations right off those inventory reports. You can see this is the pointer to the CSV here, this objects3 CSV. As I go through, I have a few more options. Here I can, here I'm going to do put copy again. I'm going to specify the destination bucket. And then I also get, for copies, I get all the options that are associated with copy in S3. So I can, say, hey, one use case for this is copying stuff into a separate storage class. So I could say, hey, instead of standard, I'm going to use intelligent tiering as the destination side storage class. I can switch the encryption, because that can be done on copy as well. I can switch ACLs, switch tags. Most properties in object can be switched on copy. So you kind of go through this menu, specify all the copy options that you want. Here I'm specifying the location of my completion report. So if I will get those 3 failed again because I'm just cloning and running the same thing without fixing that problem, but that's where my completion report will live. And then I can go ahead and just kick off my clone job, right? And so now it's telling me that I've successfully created this job, and you can see that its status now is set to new, and it's waiting it's starting up its processing. One thing that it does want me to do before it actually gets going is it wants me to do a confirm and run. Because of the scale at which you can run batch operations, you could pipe a billion objects into this thing. So we put that little safeguard in there to make you just come in and give us one more poke, like a 2-factor kind of double key kind of thingy, to make sure that you really want to run that billion object job. And when you say that you do, it gives you a nice little successful window back, and now you can see that my batch job is active. I just ran it before we came up here, so it's going to do the exact same thing as the previous job did, but that's basically how batch operations work. So this is a multi-hundred object copy. It's going to trigger a bunch of replication because I got a bunch of replication turned on, but you could scale this out as far as you want. Batch operations manages the scale for you. It makes sure that it does automatic back off against our index if throttling occurs. It does all the sort of undifferentiated things that you would need to do in order to make a billion object batch processing job work reliably. Okay, so that's my demo. Batch operations, replication time control, and access points. It's hopefully I didn't ramble and talk too fast for anyone to understand it. Thank you.